Okay, so today we're going to look at sine and cosine ratios in comparison with our tangent. So before we get started with the problems, we want to go over these formulas. Sine and cosine ratios have to do with the hypotenuse. It's a comparison of a leg to a hypotenuse. So the sine of an angle A is the opposite leg over the hypotenuse. So you can see that A is across from side BC and that leg is the opposite leg. Now cosine uses adjacent over hypotenuse, so that's why it uses the two legs that meet at A and the hypotenuse together. And you always put a hypotenuse on bottom. None of the ones you're going to study in this class ever put a hypotenuse on the top. So that's good that you don't have that kind of error that can be caught in your problem. So to compare all three of the formulas that we're using, opposite over hypotenuse for sine, cosine is adjacent over hypotenuse, and tangent, which we studied yesterday, is opposite over adjacent, we have this mnemonic. Some old hippie caught another hippie tripping on acid. And what this mnemonic does for you is to help you keep up with how the formulas are made. See, the first three letters of some old hippie, the first letter is the trig word sine, and then old hippie tells you it's opposite of hypotenuse. So CAH here would make it cosine of adjacent over hypotenuse. And tripping on acid, and I'm not advocating drugs here, people. That's what hippies did back in the 60s. And so this little mnemonic helps you to remember it, the words of what they mean. So T stands for tangent, opposite over adjacent. So each one of those helps you to remember that. Now there is another mnemonic, and that mnemonic I don't care for as much because it just uses the first letter of all those words. And if you look at that, it just seems like a bunch of random stuff. But some people pronounce it Sakatoa, and it sounds like something an Indian name would be. And I wouldn't know how to pronounce that into spelling, so I can't remember Sakatoa is the one. I remember some old hippie called another hippie tripping on acid. So you can use one of these two mnemonics to help you learn the formulas. So in this first question, we're going to go through the mnemonic with angle T, and then we're going to go through the mnemonic with angle G. So some old hippies tells me that sine is opposite over hypotenuse. So let's label our picture. Across from T is the opposite side of 8. The hypotenuse is the longest side, so that makes this the adjacent. So one of the things you may find very helpful is to go through and always label the longest side first, a hypotenuse, and then draw your line from T over to the opposite side, and then the third one will be adjacent. So if I'm going to do opposite over hypotenuse, I'm going to do 8 over 17. Caught another hippie for the mnemonic means cosine is adjacent over hypotenuse. And so caught another hippie would give us 15 over 17 for our fraction ratio. And then tangent, tripping on acid, O over A represents 8 over 15. Now yesterday we learned some relationship between the two tangents. Let's see if that relationship still holds up today. So now we're going to label it from G. So this is still the hypotenuse. Across from G is 15 now. That's the opposite side. And adjacent is 8. So when you look at sine of G, and again you're wanting opposite over hypotenuse, you're going to put 15 over 17. And then when you look at the cosine of G, that's adjacent over hypotenuse. So that's 8 over 17. And then when you look at tangent, opposite over adjacent, that's 15 over 8. So yesterday we compared the two tangent answers and realized they're reciprocals. Now I'd like you to look at the cosine and the sine of T and look at the cosine and sine of G, and how could you say they compare? Well, basically what it is if the sine of one angle is the cosine of the opposite angle. So let me phrase that. That's probably not the best way to put that. The sine of one acute angle is the cosine of the other acute angle in the right triangle. So therefore, these two always match, and these two always match. And the tangents are always reciprocals. So here you're going to look at these pictures and decide about x and y angles. So first of all, let's look at sine of x, because sine is the first one in all of these. So maybe we can narrow that down. So sine of x would be opposite over hypotenuse. So 64 over 80 is only the answer here. The other one would be 48 over 80, and then these two are switched so that cosine of y and sine of y have the opposite answers that x does. So it is C. So over here it says generalize how they're related. Well, they're not reciprocals because I didn't flip them. And we're talking about these two answers, sine of x and cosine of y. They're not reciprocals. They're not inverses of each other. They are equal to each other, but are they complementary or supplementary? And you got to remember, two acute angles make a complementary angle. So next, we're going to continue this thought by listing out just one angle, sine of n and cosine of n, cosine of m. Now this is opposite over hypotenuse and adjacent over hypotenuse, so each one's going to have the hypotenuse under it. And when you look at that, the hypotenuse is always the one around from the right corner, right angle. M is across is 7, so that makes the 24 the adjacent. So we're going to put 7 over 25 for opposite over hypotenuse, and we're going to put 24 over 25 for opposite over adjacent. So in our next question, 9 is the biggest out of all these. It's across from the right angle. This is going to be your opposite because it's across from n, so this is going to be my adjacent. So the sine of m is equal to opposite over hypotenuse, which is 4 square roots of 2 over 9. And then the cosine of m is equal to 7 over 9. So in this last one, across from m is opposite. This is my hypotenuse, so this has to be my adjacent, because the two, that's one thing you got to remember. The two legs meet at the right angle, and one leg's adjacent and one's opposite. So those two should be real easy to make sure that you've labeled them right. So sine of m is equal to opposite 2 over 4, which is 1/2. And cosine of m is equal to 2 square roots of 3 for the adjacent over the hypotenuse. But 2 over 4 reduces to 1/2, so the square root of 3 over 2 would be what you get when you reduce that. You need to always make sure your ratios are completely reduced. And the answer to the question is not just the fraction, but you have to write the sine of m and the cosine of m each time, because that's what the ratio relationship actually relates to. Okay, we're going to look at one more page, and then we're going to stop this video, and you will continue it tomorrow. So this is the opposite side, and this is the hypotenuse. So when I label my sides, I have to choose the trig word that uses opposite and hypotenuse, which is sine. Sine of 35 equals x over 20. Now, just like with tangent, we got to look at, can I cross multiply? Can I switch the diagonal? Do I need the inverse? So x equals 20 sine of 35. You'll type that in your calculator. Sine is on the same row with tangent, and out will just come the answer. I'll let you figure out these answers when we finish setting them up. So now, since 41 is across from a blank side, this must be the adjacent side since those two sides meet at the right angle, and then 11 has to be the hypotenuse. So once I realize the hypotenuse and adjacent are given, I know I'm using cosine. Cosine of the angle equals adjacent over hypotenuse. Adjacent over hypotenuse. This was opposite over hypotenuse. So I got to know some old hippie called another hippie. C-A-H, called another hippie. So now, how would you solve this? Well, you'd cross multiply. X equals 11 cosine of 41. And you can go back and type that in your calculator in a few minutes. So now 56 is across from a blank side. This is the hypotenuse. This is adjacent because the adjacent side touches the opposite side. So this is again going to be cosine of 56 equals adjacent 10 over the hypotenuse x. This time the bottom is missing, so we're going to use switch the diagonal to solve. And you'll just type that in your calculator. So now take a few minutes to type all three of these in your calculator. It says to round to the nearest tenth, so we need 1 decimal place. Okay, so now we'll come back and we'll see if you did it right. So 20 sine of 35 comes out to be 11.5. For 11, cosine of 41, you get 8.3. And for 10 divided by the cosine of 56, you get 17.9. So to wrap up this lesson for today, let's look at the escalator problem. In the subway system of St. Petersburg, Russia, they have this huge escalator. It has a vertical rise of 195 feet and 9.5 inches. A vertical rise is how much it is straight up and down. So we're going to either need that all in feet or all in inches, and we'll come back and talk about that in a minute. The rise of the angle, and since angles rise in this direction, is 10.4 degrees. How long is the escalator? If you think about your escalator being like this, going up, then our escalator length is going to be the hypotenuse. It says find your answer to the nearest foot. So the moment I realize this needs to be in feet, then that's going to change my perspective here on this number right here. I'm not going to want to change this to inches. So 195 feet plus 9.5 divided by 12. Math frac is how we'd want to look at that in terms of 9.5 divided by 12. We'd want to take that fraction and make it the mixed number of 195 something. But 9.5 divided by 12, let's see if that's a nice decimal. It is not a nice decimal. So we're going to leave it like this, and we'll type it in like that when we get our problem set up. So this is opposite. Besides the opposite side over the hypotenuse. So this is sine of 10.4 equals that missing hypotenuse. And up here we're going to put 195 plus 9.5 over 12 since that's not a very nice decimal. So we'll switch the diagonal to solve this. And we will type in this mixed number in parentheses divided by the sine of 10.4. So parentheses 195 plus 9.5 divided by 12 to turn it to inches to feet. Parentheses divided by sine of 10.4. And we find out this escalator is 1,085 feet long. And I'm rounding it to a whole number because they told me to the nearest foot. Okay, I think we need to look at one last example actually to finish out our lesson. Because I think that's what I did, but I'm just going to stop it here and we'll come back and do inverse, cosine, and sine tomorrow.